In this video, we present our work that has been accepted in CVPR 2021. Spatially Consistent Representation Learning, or SCRL for short, is a novel self-supervised learning algorithm for localization tasks. This work has been done by research scientists and engineers at Kakao Brain. Recent self-supervised approaches adopt contrastive learning frameworks, in which they maximize similarity between two random augmented views. In those works, aggressive random cropping is included as an augmentation to learn translation invariant features. For object-centric images, the global representation should be similar, no matter where the views are cropped from. However, considering multi-object images for localization tasks, the crop views may come from semantically different regions, and it can lead to the model to learn a spatially insensitive representation. The question we would like to answer is, can we make a better representation for localization tasks by avoiding this undesirable positive pairing? The main idea we propose is to consider spatial consistency when constructing the pairs. By doing so, the model can learn a location-aware and translation-sensitive representation, which can be beneficial to the multi-object localization tasks. The overall structure of the proposed model was motivated by the work, Bootstrap Your Own Latent, also known as BIAL. We will explain the training process one by one along the pipeline. First, we generate two random augmented views from the input image. Then, feed them into each Siamese network. The target network at the bottom is a moving average version of the online network at the top. And this is where we impose spatial consistency. Instead of pooling the entire feature, we sample pairs of consistent boxes from the both views and pull them individually with respect to each region of interest. Specifically, we restrict the box generation to the overlapped region between the views. And also, to promote diversity, intersection over union between all the boxes should be smaller than 0.5. Back to the overview, we feed the pooled features to projection heads that consist of a few MLP layers. After passing the online features through a prediction head, we obtain the final representations for each box. The objective enforces the online representation move towards the target representation. It's almost identical to the loss used in BIAL, but averaged over the number of the sampled boxes. Additionally, we symmetrize the loss by swapping the online and target views. In the experiment section, we show this simple idea significantly improves performance in many localization tasks. In VOC detection, using a two-stage detector, the proposed method outperforms baselines by a large margin. The improvement in AP75 is larger than in AP50, which may imply that SCRL improves the precision of bounding box regression. Also, in COCO detection task, SCRL outperforms ImageNet supervised baseline and all the other self-supervised methods. Surprisingly, SCRL performs the best even when trained only for 200 epochs, 20% of the total training schedule. We also observe the same trends with a single-stage detector, in a small data regime, and more various task types and datasets. Please refer to the paper for more details. To conclude, we propose a novel self-supervised learning algorithm that considers spatial consistency rather than global consistency. And we empirically show that this spatially consistent representation provides a clear advantage on various localization downstream tasks. Thank you for listening. Please check out our full paper and visit our GitHub repository for the code and models. This video is created with the voices from Lovo at www.lovo.ai.